Let's pick up where we left off. We are on example 10, and we're going to do the last two parts of this and then move on to the next page. We're rationalizing the denominator. So when we rationalize the denominator, the first step is to simplify these square roots. So you could right now, just like we did in the previous examples, multiply by square root of 12 over square root of 12. But square root of 12 has a perfect square in it. 4 goes into 12 because 12 is 4 times 3 and 4 is a perfect square. So what that means is that 1 over square root of 12 is really the same as 1 over 2 square root of 3 because the square root of 4 is 2. That square root simplifies. And then square root of 3 doesn't have any perfect squares in it, so it just stays put. So what this enables us to do, it makes simplifying easier. So now I'm going to rationalize the denominator. After I simplified the square root, rationalize the denominator, and what I get on the top is just square root of 3, and on the bottom I have the 2 out in front, but then square root of 3 times square root of 3 makes just 3 because it's like square root of 9. So final answer is square root of 3 over 6. And I can't reduce that because you can't combine or divide square roots with non-square roots, right? So this is the simplified version of 1 over square root of 12. All right, last one on this page, and then we'll start working with our calculator. So same thing, first step I'm going to do is simplify that square root because there's a perfect square that goes into 8. It's 4 because 8 is 4 times 2. And square root of 4 is 2. So now instead of square root of 4, I have 2. Square root of 2 just stays there. And now I can rationalize that denominator by multiplying top and bottom by square root of 2 over square root of 2. So on the top, I get 12 square root of 2. And on the bottom, the 2, that coefficient stays put, but then the square root times itself undoes it. So it's like square root of 4, which is just 2. So what I get is 12 square root of 2 over 4. But that is not the final answer, because after we rationalize the denominator, we gotta make sure our fraction is reduced. 12 divided by 4 makes 3. So final answer is 3 square root of 2. Now this is one that I think really demonstrates why rationalizing the denominator is a simplification. There are some problems like part C, maybe those seem about the same whether they're simplified or not. But in this one, this fraction is now not a fraction anymore. And I want to sort of check. We haven't checked the other ones, but the way to check is to use your calculator. And we're going to use the calculator in some future examples as well. But let's just try 12 divided by, and then 8, the square root of 8 on the calculator. So I'm going to just type 12 divided by, and on this calculator, just like a phone calculator, you have to type 8 and then the square root key. So that's the square root of 8. I type the 12 divided by, so now if I press equal, we get that it's approximately 4.2426. It's an irrational number, so it's not going to have a nice decimal. But let's try 3 times square root of 2. So 3 times square root of 2. So I do 3 times 2 and then the square root key. So that's the square root of 2, and then equals multiplies it by 3. Oh, and look, it is the same number. So in all these examples that we just did, where we started with and where we ended are the same number. They just look really different. And so we've decided, the mathematical community has decided, that it's the form where the denominator doesn't have a square root in it that's considered simplified. but these two are really the same number. We get the same value. They just look really different. Let's turn the page and do some where it looks like one fraction. So we said no square roots in the bottom of the fraction, but in this case, the first step is to sort of look at this as two separate square roots, because a fraction inside of a square root really isn't simplified. We need to think of it as the square root of the top, square root of the bottom. Square root of 25 is just 5. So first step is always simplify your square roots. Now we're ready to rationalize the denominator. So I'm going to multiply by square root of 2 over square root of 2. So now the top has 5 square root of 2, and the bottom, square root of 2 times itself, undoes the square root, so it's just 2. We'd want to check that it's reduced, but 2 doesn't go into 5, so we're done. So again, these are the same number, just written really differently, but this one's simplified because there's no square root in the bottom. All right, next one. First step, think of the top and the bottom separately. And now we've said that first we should simplify any square roots. Now there's no perfect square that goes into 5, but 27 is the square root of 9 times the square root of 3. Right, because 9 times 3 is 27. Oops, and I shouldn't make the 3 in the bottom. Don't do that. So the top now is 3 square root of 3 over square root of 5. So first, get any perfect squares out of square roots. Next, rationalize the denominator. It's the bottom of the fraction that can't have a square root. So I'm not worried about the square root of 3 in the top. It's just the square root of 5 that we need to multiply by. All right, so on the top now, I get 3 times the square root of 15. 3 times 5 makes 15. Remember, we can combine square roots with multiplication, but that coefficient out front doesn't combine with the square roots. We gotta keep coefficients and square roots separate. On the bottom, the only way to get rid of a square root is to square it. So the bottom is now just 5. And since 3 and 5 don't have common factors, that's the final answer. Great. All right, let's do some where they're sort of mixed up together. Rationalize the denominator. Remember, all that means is get square roots out of the bottom. So first step is look for perfect square factors. Don't have any. Not that goes into 10. So I multiply by square root of 10 over square root of 10. So this is 8 square root of 10 over 10. After I rationalize the denominator, I should see if the fraction reduces. Here, we can divide top and bottom by 2. So what we get is 4 square root of 10 over 5. Notice I didn't divide the square root by 2 because the square roots cannot combine with non-square roots, right? That we have to keep those things separate. So that's final answer. We're just dividing the coefficients by 2. Awesome. Next one. Multiply top and bottom by the square root in the denominator. There's no perfect square that goes into 2. So what I get is 18 square root of 2 in the top and just 2 in the bottom. Just like the last one, we got to reduce the coefficients. 18 divided by 2 is 9. And the square root of 2 just hangs around. Nice. Okay, part C. This doesn't look too bad. Being nice to us. We just multiply by square root of 5 over square root of 5 because there's no perfect square that goes into 5. So top is square root of 5, bottom is just 5, and that's it. There's no coefficients to reduce. All right, we can't combine square roots with non-square roots, so that's it. Ooh, oh wait, now you could just jump in and rationalize the denominator, but it might actually be less work if we look for perfect squares. 25 goes into 50. So you could get the same answer by multiplying by square root of 50 over square root of 50, but it's going to take a little less work, at least I think. We can try it both ways. Maybe that'd be good. If we view the bottom as 5 square root of 2. All right, so square root of 25 is 5, square root of 2 doesn't simplify. So now I'm going to rationalize the denominator. Now that my square root's simplified. Square root of 2 over square root of 2. So the top becomes 10 square root of 2, and the bottom is 5 times 2. Right? The 5 coefficient, and then square root times itself undoes it. And what this ends up being is 10 divided by 10. Let me write it out in case you don't see it. It says 10 square root of 2 over 10. Those 10s just cancel, so we just get square root of 2. Let's do it the other way just because, you know, I said it'd be the same thing, so we may as well see what that looks like. So let me just say or. So if I multiply top and bottom by square root of 50, then I get 10 square root of 50 over 50. But we're still left with, I need to simplify the square root, right? So that step doesn't go away. So I suggest doing that step at the beginning. But we can do it here. So just like up here, square root of 50 is 5 square root of 2. Right? Because it's square root of 25 times square root of 2. So we get 50 square root of 2 over 50. 50s cancel. So we get the same answer, right? And I don't even know that that was less steps or more steps. It's probably about the same. But what sometimes I see is that students who do it this way maybe stop here, or they just reduce the fraction. They forget to look for those perfect square factors. So that's what I would say as a first step. Look for perfect squares that go into your square roots. That way you won't forget to do it. Right, because here it might look like, oh, I just canceled those and then I'm done, but it wasn't like that. All right, last couple on this page. We got first, I gotta write down the problem right, but to think of a fraction under a square root as 2 separate square roots. So it's square root of 5 times square root of 3, and we need to rationalize the denominator, the bottom. So it's square root of 3 that I'm multiplying by. So the top becomes square root of 15 and the bottom's just 3. And then that's it. We're done, because you can't combine square roots with non-square roots. This doesn't work to reduce. We can only reduce coefficients. Nice. All right, square root of 7 over square root of 12. Are there any perfect squares that go into 7 or 12? Yes. 12 is 4 times 3, and 4 is a perfect square. So on the bottom, it becomes 2 square root of 3. Square root of 4 makes 2. Square root of 3 doesn't simplify. So now I'm going to try to rationalize the denominator. So I focus on what's in the bottom of the fraction and multiply top and bottom by that square root. So in the top, we get square root of 21. In the bottom, we get 2 times 3. The 2 stays 2. Square root of 3 times square root of 3 is 3. So final answer is square root of 21 over 6.